I want you to picture something for a second. Imagine you're standing on the edge of this massive, just gaping pit.
Okay. Setting a lovely scene here.
Right. And inside this pit is 2.12 billion tons of municipal solid waste.
Wow.
Yeah. That is every single piece of garbage humanity threw away last year. Literally all of it, just piled into one single place.
I mean, just imagine the smell hitting you.
Yeah, it would be awful. That heavy, suffocating stench of, like, rotting food, the dampness of the paper.
And underneath it all, that really sharp, almost stinging chemical tang.
Yeah.
You know, from mixed plastics just baking in the sun.
Exactly. But here's the crazy part. This pit, it's the ultimate feedstock.
Right.
Everyone in the clean energy world is looking at this pit and seeing an absolute gold mine. But nobody actually wants to get their hands dirty dealing with it.
It's honestly the defining paradox of the modern energy transition.
Yeah.
We're looking at a literal mountain of discards, and the instinct is to, somehow harness it.
So today our mission for this deep dive is to look at waste-to-X technologies. That's the umbrella industry term for taking all that garbage and supposedly turning it into clean fuels, electricity, and, like, valuable chemicals.
It sounds amazing.
It does. If you look at the glossy, perfectly formatted marketing presentations from these clean tech startups, they promise negative carbon emissions and endless cheap energy.
Mm-hmm.
But we are going to explore the massive gap between those pristine spreadsheets and the messy, complicated, and frankly gross reality of actual garbage.
Because the idea of a circular economy is incredibly appealing for you, the listener. We all love the concept that the very things you throw away today could, seamlessly power your home tomorrow.
Or charge your car. Yeah.
Right. It feels like the perfect closed loop. We love the end product, but almost nobody wants to look closely at the feedstock itself. The reality of what actually goes into that system is deeply uncomfortable and honestly physically rebellious.
Okay, let's unpack this. The core promise of this entire industry is that we have an unlimited supply of fuel. Because obviously, we are never going to stop making trash.
We certainly aren't.
Right. And industry analysts love throwing around these staggering, almost incomprehensible numbers. They project global municipal solid waste will hit 3.8 billion tons by 2050.
Which is just a massive leap.
Yeah. Or they point to agricultural waste. They'll say, we have 1.66 billion tons of just corn stovers sitting around on farms. It sounds like an absolute abundance, right? Like an ocean of free energy.
But having a massive amount of total trash does not equate to having a massive amount of usable trash.
Yeah.
There's this brutal physical reality that separates theoretical availability from practical collectability.
What do you mean by that?
Well, let's take that corn stover example.
Yeah.
Yes, farms produce 1.66 billion tons of it. But what the clean energy reports often conveniently leave out is that 30 to 40% of that plant matter has to stay on the field.
Oh, really? Why?
For soil health. If you strip it all away to feed a power plant, you destroy the soil, and your next harvest just fails.
Oh, wow.
Yeah. And another huge chunk is already spoken for as livestock feed. The rest is scattered across millions of independent farms with absolutely no infrastructure to collect it, bale it, and ship it to some central processing plant.
So it's like looking at the ocean and saying we have unlimited drinking water while completely ignoring the cost, the energy, and the sheer difficulty of getting the salt out.
That's a great way to put it.
The spreadsheets say unlimited fuel, but reality says you have to pick the syringes and the batteries out first.
Exactly. What's fascinating here is that the industry actually operates on a baseline they call the 30% rule.
Okay, what's that?
You basically should assume only about a third of any theoretical biomass is actually collectible at a reasonable cost. So immediately, those multi-billion ton projections just shrink.
Right.
But then you hit the second, much harder wall, which is contamination.
Yeah, and contamination isn't just someone accidentally throwing an aluminum can in the paper bin.
Not at all.
If you walk through a municipal solid waste sorting facility, you see workers in heavy protective gear standing next to these massive, fast-moving conveyor belts.
It's intense.
They are manually pulling out lithium-ion batteries that could just spontaneously start fires. Medical syringes, half-empty jugs of bleach, tangled cords. It's physically hazardous.
But the obvious physical hazards, the batteries and the syringes, those aren't even the biggest problem for the technology. The real nightmare is the subtle chemistry.
The chemistry.
Yeah. Let's actually break down how these advanced facilities work, because people often confuse it with just burning trash. Advanced tech relies on processes like gasification.
Right.
And gasification isn't burning. It's basically baking the trash at extreme temperatures without oxygen. So it breaks down into basic molecules, creating a synthetic gas, or syngas.
Which sounds incredibly efficient on paper.
It is until a piece of PVC plastic slips through the sorting line. PVC contains chlorine. So when that chlorine enters that superheated, oxygen-starved environment of a gasifier, it reacts to create hydrochloric acid gas.
Oh, that sounds bad.
It is. That gas literally eats the highly engineered steel machinery from the inside out. It causes severe corrosion and highly toxic emissions.
Wow.
Or take heavy metals. They sneak in through various consumer electronics or paints, and they concentrate in the biochar.
Biochar is the solid carbon residue left over, right?
Exactly. Which is supposed to be sold as a great, sustainable soil additive. But if it's laced with heavy metals, it's totally ruined. You just created toxic waste.
So even the good stuff is ruined.
Yeah. Even something that looks perfectly clean, like junk mail or cardboard, is usually covered in chemical inks, adhesives, and glossy coatings that just throw off all the chemical reactions.
It's like trying to run a high-performance Formula One engine on crude oil mixed with sand.
Yes.
I mean, the engine is a marvel of engineering, but if the fuel isn't perfectly refined, it's going to tear the cylinders apart.
That is the perfect analogy. These gasification plants are engineered to process clean, uniform biomass. The moment they are fed mixed municipal waste, their operational availability drops to a dismal 60 or 70%.
That's terrible.
They constantly have to shut down for intense maintenance, cleaning, replacing corroded parts, all because the chemical variability of the trash is destroying the equipment.
Which means the only solution is to intensely clean and sort the garbage before you process it.
Right.
But looking at our sources, that pre-processing, the optical sorting, the shredding, the chemical washing, that adds anywhere from $20 to $50 per ton just to prepare the feedstock.
It completely destroys the free energy narrative.
Exactly. It often makes this supposedly cheap garbage more expensive to process than if you just went out and bought pristine virgin wood chips from a commercial timber farm.
The economics of processing heterogeneous mixed waste are incredibly punishing. You are spending a fortune trying to turn chaos into uniformity.
Okay, so if mixed garbage is this chemical nightmare that breaks all the expensive machinery, the industry is obviously going to pivot to perfect, clean waste streams.
Naturally.
And that brings us to the holy grail of the circular economy. Used cooking oil, or UCO.
Used cooking oil is truly the darling of the sustainable aviation fuel and biodiesel industries.
Yeah.
It's a genuine waste product.
Right.
And it has no competing uses.
Right. Nobody is trying to do anything else with degraded grease left over in a fast food deep fryer.
Exactly.
And it gets those incredible carbon intensity scores we hear so much about.
Yes, and that's key. A carbon intensity score, or CI score, is basically a ledger of every ounce of carbon emitted from the creation of a fuel all the way to its combustion.
Okay.
Traditional fossil fuels have high CI scores because you have to drill them, refine them, and burn them. But UCO gets a massive discount because the carbon footprint of growing the crops and making the oil was already assigned to the food industry.
Oh, so as far as the energy sector is concerned, UCO starts at 0.
Precisely. On paper, it is the absolute perfect fuel.
But here's where I get hung up. There is a massive glaring supply problem. The amount of used cooking oil in the world is strictly limited by actual human cooking activity.
Right.
You only get UCO when a restaurant fries up a batch of chicken. Yet we have these massive policy incentives. You have California's low-carbon fuel standard and the European Union's Renewable Energy Directive.
Big programs.
Yeah, and these policies were well-intentioned, trying to jumpstart a green market by handing out massive financial rewards for UCO-based fuels. But they've created a voracious, insatiable appetite for this stuff.
This is where policy collides violently with physical reality. When you have functionally unlimited policy-driven demand and strictly limited physical supply, the market will find a way to bridge the gap.
Wait, you can scale up virgin palm oil by just planting more trees, but you can't force people to eat more French fries to generate more used oil. Are these policies essentially incentivizing massive global fraud? Where is the extra oil coming from?
Well, in 2023, European imports of biodiesel from China jumped by 40% in a single year.
40%.
In 1 year. And that raised massive red flags across the entire global industry. Investigators started asking, is all of this oil actually used?
Oh.
Because the data strongly suggests that fresh, virgin vegetable oils like palm oil, which is a massive driver of deforestation, are being adulterated, chemically treated, or simply falsely labeled as used cooking oil to capture those massive policy premiums in the West.
So basically, some advanced plant in Europe is running off what they think is grease from a million late-night kebab shop runs, but it's actually just pristine palm oil wearing a fake mustache.
That is exactly what is happening.
Right.
And it reveals a fundamental limit of the circular economy that we just have to grapple with.
Which is?
The absolute highest quality waste streams, the clean, predictable ones like UCO, are the scarcest. When policy outpaces physical reality, the market compensates through deception. You cannot legislate more waste into existence.
Man. Okay, so if the perfect waste like cooking oil hits a hard supply ceiling and triggers international fraud, the industry has absolutely no choice. They have to figure out how to process the messy, contaminated, mixed municipal waste.
Back to the pit.
We can't avoid the pit forever. Looking at the sources, there are two radically different paths being taken to solve this. The first path is the high-tech Silicon Valley approach. We talked about gasification, but there's also pyrolysis, right?
Yeah, pyrolysis is slightly different than gasification. It's using lower heat, also in the absence of oxygen, to melt plastics and waste down into an oil-like liquid called biocrude.
Got it.
Both are considered advanced conversion technologies, and both are currently struggling immensely.
Really?
Yeah. A perfect example in the real world is Enerkem. They are a highly respected pioneer in advanced waste gasification. But they recently announced they're retiring their pioneering facility in Edmonton, Canada in 2025.
Wait, why?
Despite years of effort and brilliant engineering, they simply could not reliably process real-world, unpredictable municipal waste at design capacity. The technology works beautifully in a lab with sorted plastics or uniform wood chips, but real trash is too wet, too variable, and too contaminated.
Here's where it gets really interesting.
Hmm.
The most economically attractive waste, the stuff you actually get paid to take, is the exact material. The coolest, most advanced technologies are completely incapable of handling.
Exactly.
So the high-tech, futuristic solution is failing the reality check. But then there is the second path, the brute force solution. Conventional, unglamorous, mass burn incineration.
The old school way.
Yeah. Modern incinerators routinely hit 85% availability or higher. You don't need a perfectly calibrated Formula One engine. You just toss the raw, wet, battery-filled garbage in, and it burns. And nobody is embracing this brute force method quite like China.
Oh, China's dominance in this sector is absolute. As of 2024, they are operating 997 waste-to-energy plants.
Almost 1,000 plants.
Yeah, which represents 23 gigawatts of capacity. That is nearly half of the entire global capacity. And to put their sheer speed into perspective, they added 13 massive new plants just between January and October of 2024.
That is insane.
They aren't waiting for perfect advanced technology to mature in a lab. They're scaling what works today.
But there is a massive environmental trade-off here. Our sources note that China's waste incineration plants emit roughly 1.8 tons of carbon dioxide per megawatt hour of electricity.
Right.
That is 3 times higher than the average for all Chinese power plants. So yes, they are getting rid of the garbage, but they are pumping huge amounts of CO2 into the atmosphere to do it.
It's a real issue.
Though, to be fair to the data, their air pollution controls like scrubbing out the toxic chemicals and heavy metals from the exhaust have improved 100-fold since 2004.
If we connect this to the bigger picture, China took a highly pragmatic approach. They realized that rapid urbanization produces literal mountains of trash, and burying it all in landfills simply wasn't sustainable for their land use.
Makes sense.
So mass burn incineration solves the physical waste problem, but it creates a long-term climate problem by locking in decades of high-emission energy generation.
And this leads to my absolute favorite detail in the sources. The ultimate paradox in all of this is happening right now in Beijing.
It's so ironic.
It really is. Beijing has actually been incredibly successful with its public recycling and waste sorting programs. They are so good at diverting trash away from the incinerators that their massive multi-million-dollar incineration plants are only running at 76% utilization.
Which is a huge financial problem for a plant.
Right. So what do? They are ironically forced to import 1,200 tons of raw garbage a day from neighboring provinces just to keep the fires burning.
Once you build a massive incinerator, it becomes a hungry beast. You have to feed it thousands of tons of trash every single day just to justify the massive capital investment.
So the high-tech stuff needs clean waste that doesn't exist, and the low-tech stuff handles the dirty waste but pumps out carbon and demands to be fed constantly.
Exactly.
Okay, so if the high-tech stuff is breaking down and China is successfully burning half the world's garbage in these massive plants, why am I not seeing one of these mega incinerators being built in my city right now? It seems like a solved physical problem.
That brings us to the bizarre economics of this industry. In almost any normal manufacturing business, your raw materials are your biggest cost. You have to buy steel or lumber to make a product.
Sure.
In Waste to X, you get paid to take your raw material. These are called tipping fees. Waste processors charge anywhere from $35 to $85 a ton just to let a municipal garbage truck dump its load at their facility.
Oh, wow.
And in places where landfill space is extremely tight, like Massachusetts, that tipping fee can hit $200 a ton.
So in a normal business, your raw materials are your biggest cost. Here, your raw material is your biggest source of income. That completely warps how you design your business.
Yeah.
You aren't intrinsically incentivized to make the most efficient, clean energy. You're incentivized to take in as much trash as legally possible.
Precisely, and that's before you even factor in the policy credits we discussed earlier, like California's low-carbon fuel standard. That can add another $50 to $200 of value per ton of CO2 equivalent.
So the money isn't really in the power?
No, the entire economic foundation of this industry is driven by local tipping fees and government policy incentives. It isn't driven by the inherent market value of the electricity or fuel being produced.
Got it.
And because policies change with different political administrations, it creates extreme boom and bust cycles for investors.
But let's say the money makes sense on paper. You still hit the ultimate roadblock. NIMBism.
Not in my backyard.
Exactly. The data shows that 80% of proposed waste facilities face fierce community opposition.
And you can understand why. Put yourself in the shoes of someone living a block away from a proposed site. It's not just a stationary building.
Right.
It is a continuous 24/7 convoy of heavy 18-wheeler garbage trucks rumbling past your local elementary school. It's the persistent rumble of diesel engines, the exhaust, the dust, and, depending on the wind, the smell of municipal waste.
Yeah, nobody wants that.
When companies come in pitching their advanced gasification pyrolysis plants, the residents just see it as fancy incineration and they fight it tooth and nail.
Which limits how these plants operate logistically. Because of those transportation costs and the massive traffic concerns, a plant's collection radius is usually limited to 50 to 80 kilometers.
You can't just build one mega plant in the middle of a desert.
Right, you have to build dozens of smaller ones close to the urban centers where the trash is actually generated. And each one of those faces a grueling permitting battle that drags out for 2 to 4 years.
This raises an important question, though, about environmental justice. We have to ask, where do these facilities actually get built?
That's a good point.
When wealthy communities with political connections and deep legal defense funds fight off a proposed waste facility, it doesn't mean the facility disappears. The trash still exists.
It has to go somewhere.
Exactly. It usually means the facility gets relocated to a lower-income community that simply lacks the resources to fight a prolonged, multi-year zoning battle.
The trash always flows the path of least political resistance.
It does. The burdens of the circular economy, the heavy truck traffic, the localized emissions, the industrial noise, they're not shared equitably.
No, they aren't.
The wealthier neighborhoods generate the bulk of the complex, single-use packaging waste, but the lower-income neighborhoods end up living right next to the industrial plant that has to process it.
That is a very heavy reality, and it brings up the deep philosophical conflict at the heart of all this, the waste hierarchy. The golden rule of waste management has always been reduce, reuse, recycle.
Right.
Energy recovery, burning it or gasifying it for power is way down at the bottom, just one step above burying it in a landfill.
We see this tension clearly in Europe. Countries like Denmark and Germany have incredible recycling cultures. They sort meticulously. But they still have residual waste, the complex, multi-layered plastics, the contaminated food packaging that simply cannot be recycled economically. So they incinerate that residue for energy. It solves their immediate landfill problem.
But at what cost?
Exactly. Environmental critics argue that the very existence of these highly expensive energy recovery plants creates a perverse incentive against reducing waste in the first place. You have to feed the beast.
So what does this all mean for you? When you diligently wash out a plastic peanut butter jar and put it in the recycling bin, you assume you are doing the right thing for the planet.
Of course.
But is it actually better to spend the energy turning that jar into a new, slightly lower quality plastic bottle? Or does the multi-million-dollar waste-to-energy plant down the road secretly need your plastic bottle to keep its fires burning and stay economically
It
viable?
is a disturbing thought.
Are we discouraging real waste reduction because we literally need the trash to make the financial math work?
That is the multi-billion-dollar question. It highlights that the circular economy isn't some frictionless loop. It has immense inertia and conflicting incentives.
As we wrap up this deep dive, synthesizing all these sources, the core takeaway seems to be that Waste to X is not the magical silver bullet that the startup marketing brochures claim it is. It is a bridge technology.
A necessary bridge, but a distinctly messy one. We cannot ignore the 2 billion tons of waste we generate annually.
It's physically there.
Yes, the abundance of feedstock is a physical reality that has to be managed today. But the industry must have honest conversations about the equally brutal realities of chemistry, contamination, market fraud, and community resistance.
Right.
Advanced technologies will keep improving, but they are not magic wands. The other side of that bridge likely involves a transition away from hyperconsumerism and vastly improved material science, so we stop creating complex, unrecyclable trash in the first place. Until then, we are managing symptoms.
It really resists all the simplified narratives. But before we go, I want to leave you with a final thought to mull over. Something that turns this whole geographic and industrial bottleneck on its head.
Okay, I'm intrigued.
We talked about how transporting garbage on diesel trucks is incredibly expensive, and how building massive central processing plants angers entire communities. What if the future of waste to energy isn't industrial at all?
Meaning we bypass the central plant entirely.
Think about it. What if, a few decades from now, the solution is a decentralized appliance sitting right there in your own garage?
Oh, wow.
Imagine a high-tech microdigester, about the size of a washing machine. You put your household's daily, messy, unsorted trash into it, and using advanced miniaturized tech, it directly converts that material into the electricity that charges your EV and powers your living room lights.
That would be revolutionary.
It would completely render the municipal garbage truck and the local mega incinerator obsolete. Instead of standing on the edge of a massive, foul-smelling pit containing billions of tons of humanity's collective waste, your garbage never even leaves your driveway.
Now that is a truly circular economy.
Something to think about the next time you take out the trash.